The repository design pattern in C# is one of the most used design patterns in real-time application. So, what does it do? Its main responsibility is to decouple business code from the data access code. Like Entity Framework is giving us separation of concerns by making a connection to the database, repository pattern gives us separation of concerns from the database context. So it provides us one more layer of abstraction. It also helps us avoid writing the duplicate code. For example, we have 5 different controllers, and somehow all the controllers need to fetch the list of courses. Without repository pattern, we'll have to write the same logic 5 times. But if you're using repository pattern, we can write it once and import it in all 5 different controllers. Not just that, repository pattern makes testing of the code much more smart and efficient. It's much easier to test the method inside repository pattern rather than testing our store context. Obviously, it's not easy to understand it right away, but the more you work with repository pattern, the more you get familiar with its advantages. Well, there are developers that criticize the repository pattern. According to them, it's too much abstraction of the code because Entity Framework is already an abstraction. Using repository pattern and Entity Framework in the same project means abstraction away from abstraction. I don't deny it, but it always comes to the personal choice. It's one of the most popular pattern, so you can imagine there are more goods than bads. If we don't use repository pattern, our request is first received by the controller. Our controller then forwards the request to the DB context, which is our store context, which converts the query into SQL query and interact with the database. Although there is nothing wrong with it, but if you're using multiple controllers, it's always good to use repository pattern. With repository pattern, the controller forwards the request to the repository. Repository then forwards the request to the DB context, which finally interacts with the database. It's now time to implement it. First thing we need to do is to create an instance for our repository. An interface creates a contract with the actual repository, which means our repository needs to follow everything our interface says. Our entity project will contain all our interfaces, and our infrastructure project will be responsible for implementing them. Let's create another directory inside the entity project and let's call it interfaces. In C#, it's a convention to name the interfaces by prefixing I. So our interface will be called I course repository. Make sure you're right clicking and clicking on new C# interface and not a class. Inside our interface, we have 2 methods right now. Let's create them. First of all, whenever we are doing something asynchronously, we use task class, which represents some work that should be done. The task can tell you if the work is completed and if the operation returns a result. Then the task gives you the result. In the first method, we want to return a course, so we can write task of type course, followed by name of the method, which is going to be get course by ID async, which will accept an ID and the ID will be of type integer. Since we are using task, we need to import it using system.threading.tasks, and the error is gone. Our second method will return the list of courses, so we can write task of I read only list. List will be of type course, so let's mention course here. And the name of this method will be get courses async. We are not providing any parameters here. So we need to import I read only list. So put a cursor over there and press command and a period and click on using system.collections.generic. And now we have it. iRead-only list needs to be used when the sole purpose is to show the result and not the mutation of it. Our interface is now ready. We just need to create a class which implements it. As I said before, I would like to implement it inside the infrastructure project. So let's go there and inside and here create a new class and let's call it course repository, which will import our iCourse repository interface. What we need to do here is to implement iCourse repository. We will put a colon here followed by the name of the interface, which is iCourse repository. Now put a cursor over here and press command and a period and click on using entity.interfaces. It still shows an error because we haven't implemented it yet. So let's do again, press command and a period and click on implement interface. This will bring both our methods in this class. Before we start writing these methods, we need to add this as a service if you want to use them inside controllers. For that, we need to go to our startup class, which is inside our API project. So click on startup.cs. Now we can add this service inside the configure services method. The order here really doesn't matter, unlike the configure method, which is for our middlewares. So we can write a method anywhere inside the configure services method. Let's write it here, services.add. After the services, we need to mention the scope of this service, which means how long we want this service to be available for us. In our case, the repository will be injected into our controllers, which means a new instance of this repository will be created when we make the HTTP request to the API. We can use add transient, which gets instantiated for the individual method and not for the complete request. So we can say it has a comparatively shorter lifetime because it will be created and destroyed upon calling the individual method, which is way too short lifetime for us. Another option is to use add singleton. This will be created for the first time we use it, and this will be running all the time till the service shuts down, which means this is too long for us. So the correct option is to use add scoped. This one can be used for any instance really. Unlike you want anything very specific, add scoped will be created when the HTTP request comes to our API. Controller then knows it needs to create a repository. It creates an instance of this repository until the request is finished. After it's finished, it disposes both the controller and the repository. Now we know about these life cycles. So let's use add scoped. We need to mention the name of the interface, which is called iCourse repository, followed by a comma and the name of its implementation, which is called course repository. Now we need to bring iCourse repository using entity.interfaces, and if course repository is not available, you can import it using infrastructure. Let's go back to the course repository class and start implementing it. Before writing any code, I would like to remind you that we are going to inject our store context here and remove it from the controllers. Our controllers will then use this repository instead. Now we need to create a constructor. Go to the course repository and open quick fix using command and a period and click on generate constructor course repository. All we need to do is inject our store context here. So let's write store context. Let's simply call it context like that. This time we need to use quick fix on the context and initialize field from parameter. Now all we need to do is to use the context the same way we did in our controllers. Since we are using an asynchronous function, let's write async keyword in front of the functions. Async. Now all we need to do is return await context dot courses dot find async, and we will provide the ID as a parameter. Let's do the same thing in the second method. We will return await context dot courses dot toList async. We need to use quick fix to import using Microsoft.Entity Framework Core. This looks good now. Let's go back to our courses controller. We can use command np and write courses, and we find our courses controller here. Now we have to use the repository instead of this context. So we can take off the context from here. We can remove it as well. Now instead of using the store context, we can use I course repository, and let's name it repository. Now let's import it using quick fix, and again let's use quick fix to initialize field from parameter. Now we just need to replace the context here with our repository method. Now we can take that off. If we write underscore repository dot get courses async, it will give us an error, and it says we can't implicitly convert type iRead-only list to generic list, because here this one is a generic list instead of the iRead-only list. To resolve this issue, we can save this data in a variable called courses, and we can return courses with OK. OK creates an OK object result object that produces 200 OK response. The same way, let's use the repository methods inside here. So it will be underscore repository dot get courses by ID async, and we can provide ID here. We see an error because in our repository and our interface, we are using int, but it should be quid like here. If we go to our interface, we see we are using an integer, but it should be a GUID. So let's call GUID and import it using system. The same way, let's go to our repository and replace this integer with a GUID. Let's use the quick fix here as well, and the errors are now gone. Make sure the backend server is running. We can run it using .NET watch run. Now we can open Postman to see if the requests are working. So let's try this first, and this request is working. What we can do is we can copy an ID to see if the get course request is working, because it takes ID as a query. So just replace this one with the ID I have copied, and let's try send. This works fine as well. Amazing. We have refactored our application to repository pattern.
If you want to keep learning about how to build real-world apps with the latest technologies and other career-related topics, then start right now by subscribing to our channel and liking this video.